Hello everybody, back to calculus and statistics. This is topic number 2, week number 5. You remember last week we started talking about data presentation and statistics, where we discussed the different ways to represent data as a tables, figures, pictorial presentations, and so on. We classify them. We have example on each one of them. Today I will talk about statistics, so I'll take you about statistical summaries, then example exercises and the applications. Have a look. Now you have set of data, let's say 1,000 data, million. You need to look inside these data. So you may build them in a table or in a figure, but not much information will be, let me say, extracted from the table as example. But you can summarize these data by some numbers or figures, what we call them. Okay, this figure give you indication about your data. Example is the mean. You learn, for even if in secondary school, you use the mean to judge the data. As example, if you have exam marks for 10 students and you want to find the average, you add these marks, you sum them, and then you divide by 10. It gives you indication about the average, and we use this average to judge your class, your students. As example, if the average is 90%, this means that the student did well in the exam. If they got 30%, they did not, they are not well in the exam. So it gives you indication. I mean, you decide that they have a good answer in the exam or not good answer enough in the exam. So this is example about summaries, statistical summaries. So let me classify them into mean. I will talk about different type of means, and then we go to variance and the standard, or let me say standard deviation. Now average, or what we call it in general name mean, it's arithmetic, let me say, sum of all distributed individual data divided by their numbers. As example, 10 data, we add them, we divide by 10. For median, okay, for median, this is mean. For median is the midpoint of the data. It means 50% up, 50% low. Okay, so it is in the middle of the data. While mode is the most frequent data occurred. I mean, as example, one of let me say of the numbers in your data frequently appear, let me say 5-6 times. So this is the mode of your data. Okay, now let me start with more details, one by one. Now if as I mentioned, mean here, which is the, as I mentioned, the average, the general average, okay, which represented by x dash. X dash is the summation of all items divided by the number of items. Very simple. Example, let's take example. Here you have, let me say, name of professors, 12 professors here, okay, and this is their weight in pounds. Okay, when we add them, add all of them, okay, and divide it by 12, it gives me the mean, or let me say the average. Okay, now it's good, but average is sensitive to outliers. As example, if these 12 are, you can see the weight is normal in all of them, excluding one professor. He's overweighted, right? So this number will reflect on the average and mislead your data. Okay, when you try to understand your data, it's mislead you, right? Because there is one odd number. So any odd number in your data will not be discovered by the average and reflected on wrong impression about your data. So it's not preferable, by the way, it's not preferable to depend on one statistical summary. You need to take more than one, because you are looking from different side views. Another example of average or mean is a systolic blood pressure of 7 middle-aged men were as follows. He gave you 7 men. This is 1, 2, 3 their pressure, and we want to find the average. Then we will add them, as you can see here. We added them, summarize them, divided by 7, it gives you the average. This is the average of this group of men. For median, as you can see here in this figure, is very easy. 50% to the left, 50% to the right. okay, is the value, as in the definition here, of x in such a way that 50% of data is less than or greater than it. Now your data could be odd or even data. As example, if you have 7 samples, this is odd. If you have 8 samples, this is even. If 7 samples, it means item number 4 is the median, because 3 before, 3 after, 3 samples. But for even, we will take the item number 4 and 5, because they are in the middle, add them and divide by 2 to give you the median. Okay, example, have a look at the same example for a professor's weight. Okay, what we are going to do to find the median is to arrange them either from the lowest to the highest or the opposite. Anyway, they are 12, so we expect item number 6 and item number 7, we add them and divide by 2 to give you the median. Percentage, sometimes we want to compare different, let me say, variables with different units, so it's preferable to compare based on their percentage. Okay, I mean, multiply by 100% and then compare between them. For mode is the most frequent, let me say, point or data sample appear in your set of data. And by the way, mode and median could be found from the definition, or we can find them from the histogram, as we will explain later on. Frequency and cumulative hexagram. Example of the mode, the same example for the professors, as you can see here. We will look to the which data sample repeated frequently. We can see 165 and 100 appear here and here, which is repeated twice, so we'll say then the mode of this data is 165, as you can see here. Okay, now more examples. Let's assume n is odd, the number of samples is odd, and pressure, you remember systolic pressure for the 7 men. Okay, we arrange them from the lowest to the highest. Now they are 7, so the middle is number 4, this is the median. And we look to the frequently appeared, which is 124. It seems to be this is the mode. Another example about n if it is even. Let's say we have even numbers. Example, this 6 men with high cholesterol. Now the example about cholesterol, this is their measured cholesterol. Now we will arrange them, these numbers, arrange them from the lowest to the highest. Now the median is the middle, so what we will do, we will add item number 3 and 4, as you can see here, and divide it by 2. It gives me the median, because this is the middle. And if we go to the mode, see which one is frequently appear, 174 here and here, so this is the mode. Now these are exercises to be solved in the class. Now measures of dispersion. This is another side view to look to your data. Now we don't want to summarize them, we want to see the dispersion of the data, how they are distributed around the average or the mean. Okay, so what we will do, we will use 3 items or 3 variables here: the range, standard deviation, and variance. We will discuss them. Now it gives you impression about how your data, let me say, disperse around the average, how they are far, what is the distance between them, what is their variability. Okay, now range, we discuss it in week number 5. It is the difference between highest to the lowest. But standard deviation measure the distance from the mean. Okay, to find the standard deviation we need to find the variance, and variance is a numerical value that measure the dispersion of data. How we calculate it? Variance, which is represented here as S square, is summation of each item minus the average rises to power 2, and when we do the summation here, we divide it by the number of samples minus 1. Very simple. Let's do it an example. Okay, but before this, regarding standard deviation, it's the same variance, we just need to take the square root. As you can see here, we took the square root for variance. As you can see here, it gives you the variance, and then if we take square root, it gives you the standard deviation, as you can see here. Another parameter is the coefficient of variation. Coefficient of variation, it's give the values in percentage, the standard deviation like in percentage. Why? Because we are dividing standard deviation with respect to average and multiply by 100%. So it gives you in percentage, and this way you can compare with different variables, let me say with different units. The previous example here, you can see here, we divided the standard deviation by the average multiplied by 100%. It gives you 14.3%, which means that the standard deviation is 14.3% larger than the mean. Another example is calculate the average, mode, median, standard deviation of coefficients and of variation of the lighting time. Now you remember we used the same example previously in week number 4. Okay, now I will use the same example, 20 samples, as you can see here. These are the samples of TB. Okay, for the bulb, time for the bulb. Now we will find xi minus x. First of all, let me find x dash. As you remember, x dash is xi summation of all of divided by 20, because the number of samples 20. We got it. Now I will subtract each xi, you see here, 10 minus 0.4 minus the average. It gives me this one. 8.1 minus the average. It gives you, sometimes it's coming in minus, you see, a negative sign. Now take the square. I will take the square for this one, for this one, for this one. Then do the summation. I added them. Then divided by the number of samples minus 1, 20 minus 1, 19. So I divide them, as you can see here. These are the summation, okay, and divided by 20 minus, it gives me the variance. I take the square root, it gives me the standard deviation. I divided standard deviation by the average and multiply by 100%, it gives me the coefficient of variation. Another way to find the mode here is by using, you remember the relative frequency for the histogram. This is histogram, okay, for the data just being discussed in table. We plot this in week number 5. I can use it to find the mode. How? Have a look. I come to the highest bar. This is the highest bar, okay. I go to these two corners. The corner here to the left should be, we make a line, we should make a line between this corner and the next highest bar to the right. Okay, this is not the highest bar, or this is not, this is the bar. Okay, so I will go to this corner also and make a line. Okay, the same thing, I will come to this corner and look to the next highest bar to the left, the opposite, this one, not this one. Okay, so also I will connect. You see, the point of intersection here between the lines represent the mode. Very simple, we can find it from the graph. For the median, we can find it from cumulative frequency. The previous one, relative frequency, here is the cumulative frequency. If you remember, from 0 to 1, our data, put them here, because you know that it's 0.5, it means 50%. So 50% of the data lower, 50% of the data higher. These exercises to be solved in the class. Another example, a power plant shutdown of a certain number of hours per month, SD we call it, shutdown, okay, for maintenance. The table below lists 16 records, so only 16 samples, shutdown, SD in hour per month. Plot the histogram, cumulative frequency diagram, SD, calculate average, mode, median, standard deviation, coefficient of variation, SD. It seems to be this example will summarize everything, almost everything discussed in week number 4 and week number 5. Now for histogram, it's a procedure. We have n, which is 16. We have formula to find k, the classes or the groups. 1 plus 3.3 log 16. We got this value 4.9. We approximate to integer. Now highest value from the table is 3.2 and lowest is 1.1. So we need to find the range. We subtract them. Now divide the range over the number of classes is give you the width. Okay, we build our table as we learned before. We have five groups from 1 into 5, and then each one is started from the lowest value plus the width, next plus the width, next, and so on. Then we look to the table and we list the observations. 4 samples in the first group, 6 in the second group, 3, 2, 1. If I add them, it's supposed to give me 16 samples. And then we divide 4 over 16 and so on. We go the frequency, relative frequency, and then we go for cumulative as we learn in week number 4. Now, summation of all values. Okay, this is the summation. If it divided by 16, it gives me the average. And variance in that, or let me say deviation, xi minus x dash square from the samples we have. If we divide it by n minus 1, 16 minus 1, give me the variance. If we take the square root, as you can see here, it gives me the standard deviation. Now, I can find also coefficient of variation by dividing standard deviation over average multiplied by 100%. For mode and median, I can find them from the table, but let's find them from figure. Okay, for mode, we plot the relative frequency as you can see here, and we have these 2 points. This point connected to this point because this is the highest next to the left. For the right, this is the highest, so we connect it here to this point. Point of intersection will give me the mode. For the median, we plot the cumulative from the data from the table in the previous slide. This is 50% as you can see here. So this is on x-axis is the median. Median taken from the and mode taken from the x-axis as you can see here. Also, this exercises we will solve them together in the class. I will stop here and hope to continue for week number 6. Thank you very much. See you. Bye bye.